Continuing our lectures over Chapter 6, Objects and Classes. They have a slightly different definition, means the same thing as what I gave for a class. Let's go take a peek. If we look on page 8, a class is a description for a set of objects. A description consists of a list of variables and a list of methods. Now, if you recall what I said, a class is a blueprint for an object that contains data and the methods that act on it. Same thing. So there are two different kinds of variables that you can put into a class. A so-called instance variable and a class variable. And class variables are declared with the word static. This chapter is not going to talk about class variables otherwise. We're going to talk about instance variables. What is an instance variable? It doesn't use the word static in front of it. And it differs, or it can differ, on an instance by instance basis, right? One patient can be 6'2", another patient can be 5'5", a third patient, could be 4'3", right? Each instance, each object, each patient has a different height, or at least it can, right? So, that's what we mean by instance. An instance is an object. When you create an object, it creates an instance of that class. And then the variables for that can differ on an object-by-object basis, a so-called instance-by-instance basis. The terms instance and object can be pretty much considered interchangeable, except that, can't even think of a way that they differ. So the instance variables specify the type of data that the object can store. You have a class for computer objects. The computer class might contain a hard disk size instance. When we get to slide 11, we see a UML diagram for a lab rat, lab mouse class. So, as discussed in the last lecture, in the UML, the top part gives you the class name. The second one gives you the list of variables, the data, and the third one gives you the list of methods. And they're throwing different terms at us. Right? They're calling the variables, they're saying that attributes is an acceptable alternate name for variables. Okay, fine. They're saying that operations is an acceptable alternate name for methods. Fine, but we're going to use methods and we're going to use variables. So our particular mouse here has several different things. Got an age, a weight, and a growth rate. And then we can set the growth rate, and we can make it grow, and then we can display all the information for it. And they give us all the code for this, so that's no fun. We'd rather make our own. So why don't we make a rat class? Rat class is going to be about the same, but it may contain a few different pieces of data than this. What I'm thinking is, as well as the age and the weight, we might throw in a name, right? Each rat needs a name, so we're going to throw in a name variable. And so we are also going to add a getter for the age and a getter for the weight, which are not listed here. So when we create our rat class, it's going to kind of look like this. If I can make this larger, we're going to call it rat rather than mouse. It's going to have name, which is a string. It's going to have set name. It's going to have get name, get age, and get weight. Now, since name is a string, set name needs to accept an argument. So we're going to declare a parameter variable. Name, which is a string. Get name doesn't need an argument because we're asking it for its name, but it returns a string. Get age, well, age is an int, so it's going to return an int. And weight, going to return a double. Every time we call grow, it's going to increase the day by 1, and it's going to increase the weight by the rate of the growth rate. So, you know, if it's a 10% growth rate, next time we call grow, it's going to be its weight plus 10% more, so on. So this is a UML we're going to implement. So I'm going to go over to NetBeans. I haven't installed NetBeans 11 on this one. I'm still using NetBeans 8 on this particular Mac, so it's going to look a little bit different, but that's all right. I'm choosing Java here, which is the same thing as ANT up on your NetBeans 11 if you're using that. If you get stuck and Java doesn't seem to work, ANT doesn't seem to work. Some people have had problems getting it to install. They click the next and then it says read error. I don't know what's up with that. You can always try Maven as well. The nice thing about choosing ANT or Java on NetBeans 8 is that gives you the opportunity to create the main class right on the spot, so that as soon as you open a project, you're ready to edit. So let's call this Lecture C. And what I would appreciate you would do is when you're creating the main class, if you would take the package declaration out. You can do that right here by removing the decimal, the point, the dot, and everything in front of it. So our main class is just going to be Lecture C. It's not going to be in a package. I think I've talked about that before. It's just slightly easier for me to grade, and if you ship the code to somebody else, then it would compile cleanly and they wouldn't have to make any changes to it. Alright, apparently I still have some other things open. Here's my Lecture C. Alright, I need to make a rat class. Again, as I said, every class should be in its own file. And for the purposes of keeping all the code on one screen, I am actually going to put it right in the same file. How do I get away with that? Because although the class name and the file name have to match, that's for the public class. You can stick multiple classes in the same file, but only one of them can be public. That's another strong reason for putting every class in its own file, so that, you know, multiple things can use that same class. But I'm going to go ahead and create a rat class. Let's increase the font size just a little bit if I can. It's in a different place on Mac than it is on Windows. I believe under Windows it's under Tools, and on Mac it's under Preferences, something like that. Increase my font size just a little bit more, maybe to 20, 21, 22. All right. All right, here we go. So what does our rat class have? Looking at the UML, it had an int, it had a weight, it had an age. We've decided to add a name, right? Age, weight, name, and then a percent growth rate. So let's do that. Int age, double weight, string capital S name, double percent growth rate. And these are all actually going to be private. We're going to make them private so that if we create a rat down here, we will not be able to change them. We will only be able to access them through the methods that we provide. It is a good idea to always make your data private, and then you can make your methods public, and the methods are the interface between the data and the client code. So down here, if I was going to create a rat, rat r1 equals new rat, parentheses in, parentheses, semicolon. Now this should be enough to get it to build. I click build. Where's my object? My output. There it is. See if I can get that down here. Yeah. It did build. Go back. Add some things. One thing, we're going to make these private. Private int age. Private double weight. Private string name. And private double percent growth rate. Alright. Now in the last lecture I showed providing getters and setters. for the variables. NetBeans makes that extraordinarily easy. I could provide a getter and a setter for every single one of these variables in about 10 seconds. Just as a reminder of what a getter and a setter is, let's go ahead and implement one for age. Although, according to the UML, we're not going to allow them to set the age. That's going to be handled entirely by how many times we call grow. But just to demonstrate getters and setters, let's make a getter and a setter for age. A getter returns the age, so public int get age. The convention is to make the getter use a capital letter for the first, for age, for the first word, for the variable name. So get capital A-G-E. And then what's it going to do? It's going to return this dot age, semicolon, close brace. And now I want a setter for it. Since it's setting it, it doesn't need to return anything, but we need to allow it to pass in an argument. So we're going to declare a parameter variable between the parentheses. Public void set age, capital A, int age, in the parentheses. And inside its curly braces, this dot age equals age, semicolon. Okay, so that took 10-20 seconds worth of typing, but we can do it much more quickly by using the refactor menu. Specifically, we're going to use the one that says encapsulate fields. Encapsulating fields means we're going to take these pieces of data and we're going to provide getters and setters for them. The only way they can be changed is through the getters and setters. Encapsulated, they're protected by a capsule, a layer. Let's go ahead and do that. What I'm going to do is I'm going to highlight the three variables, weight, name, and percent growth, refactor, encapsulate fields. And if we look, what's the screen doing? It's saying that when I click refactor, it's going to change. It's going to add a get weight, get name, and get percent growth rate. And it's going to add a set weight, set name, and set percent growth rate. If I did not want to provide any setters, if I only wanted to provide getters, they're read-only in effect, I could deselect them. Now since age already has a get age and a set age, we certainly don't need to click them. I guess that's what the circle there means, is that they're already created. Okay. So the fields are going to be private, which we already made. The accessors, the getters and the setters, are going to be public. And you can just leave the insertion point at default, or you can say I want it to be the first method or the last method. If you do the default, and I'll show you what the default does. Why not? Refactor. The reason I don't like the default method is it put all my getters and setters above the variables, right? It's ugly. And notice it added all of these Java docs and expanded them out, right? But that's okay. When that happens, great. But go ahead and take your four variables, your four instance variables, and cut them and move them back up to the top of the rack class. We'd like to see our variables there. So the next time I do a refactor, I probably won't leave it in the default setting. So you saw what I did. To repeat that, I highlighted everything. I chose refactor, encapsulate, and then I chose the ones that I wanted to create, and I chose refactor. And from now on, I'm going to change the insertion point to be the last method, something like that. Okay. So there we go. I'm not going to edit these to make them look like that, those two, but I could, right? I could remove all the, the extra space and put them all on one line, just like I have here. Okay, so when we create our rat, we could set its name, r1.setName, parentheses, quote, Ricky, end parentheses, end quote, end parentheses, right? And we can set its age. It's going to start off at 1 day old. set age parentheses 1 in parentheses. We could set its weight. I don't know how much a baby rat weighs when it's born. Let's say 5 grams. R1 dot set weight parentheses 5. If we were good programmers, we would have added comments to the effect that the age is in days and that the weight is in grams. So I could scroll up and do that, right? The age is in days and the weight is in grams. If we were more awesome, we would have said weight in grams, right? Something like that to indicate, but I'm going to undo that. Okay, we have a couple of more methods to add. There's going to be one called grow. Every time we call grow, it adds 1 to days, and it increases the weight by the % growth rate. So, just make it easy to spot where I'm adding it. Usually I put my other methods below the getters and the setters. I would do some judicious cutting and pasting before. I turned this into code that I wanted to give to somebody else. I'd put all the setters and the getters, next, and I'd make them all nice and tidy. But for now, void grow, because grow's not going to return anything. If we went and looked at our UML, we would see that was the case, right? They do not put the word void after everything that doesn't return anything. I wish that they did. I wish that all their UMLs had that to indicate that it didn't return anything. But we're smart enough to know that in their UML, if a method does not have a return type, that we have to declare it as void. So, no return type, no parameters, as they were not defined here. What does it do? It increases the age by 1. This dot age plus plus, add 1 to the age. And we're going to increase its growth. This dot age, and there's more than one way to do this, but plus equals this dot age asterisk this dot % growth rate. And just for fun, why don't we make the grow method print something to indicate that it's growing? So system.out.println parentheses this dot name plus quote is growing exclamation mark end quote in parentheses semicolon. So every time we call grow, it's going to get bigger, it's going to weigh more, it's going to get older. We haven't built it recently, so let's build it, but let's give a few calls. So this is the function that I just added below all my variables. All the getters and setters are below that. Now I'm going to scroll down to the client code in main. Notice that these are two completely separate classes, right? Class rat begins and ends. And then there is our client cat class, our driver class, and that's where main is stored. Okay, so now that we've created Ricky, we're going to make him grow. R1.grow, parentheses in parentheses. Maybe he's going to grow 3 days. R1.grow, parentheses in parentheses. And then R1.grow, parentheses in parentheses. It occurs to me that we could make a grow method where you passed in the number of days that you wanted it to grow. And it would loop, right? If I said grow parentheses 10, then it would loop, growing itself 10 times. Let's see what happens. I'm going to build it, hammer and broom. Seems to work. I'm going to run it. Ricky is growing, Ricky is growing, Ricky is growing. Okay. We need to find out some information about the rat. Right? We're going to add the show method that they have mentioned here. Excuse me, display. Display displays information about it. So we're going to print out its age and its weight and its name. So let's go back up and either above or below the grow method, void display, parentheses in parentheses, curly brace, system, let's use printf, system.out.printf, parentheses, quote, rat name equals %s space, age equals %d days, and the weight equals %f grams. \n, end quote, comma. I'm going to go and modify this formatting string a little bit more. Rat name equals %s, comma, age equals %d days, comma, weight equals %f grams. \n, end quote, comma, and then we need to pass in the arguments that fill in these placeholders. So, name, days, name, age, and weight. So this dot name, comma, this dot age, comma, this dot weight. And then a closing parentheses and a semicolon. Alrighty, let's run it. Well, I didn't call the display method, so it's not going to behave any differently, but there's nothing wrong with building it after making a change. Okay, it did build successfully. So I'm going to scroll down, back to my client code, my driver, down here in main, and after he grows 3 times, I'm going to call display. r1.display, parentheses in parentheses. Hammer and broom to build it, green arrow to run him. Ricky is growing, Ricky is growing, Ricky is growing. He's now 4 days old and he weighs 5 grams. Maybe we want to initialize his age to 0 rather than 1. I'm going to change that to 0. Let's write a loop. Age Ricky, for a month, 30 days, something like that. So, int day equals 1, semicolon, while parentheses day less than or equal to 30, end parentheses, curly brace, r1 dot grow, in parentheses, begin parentheses, end parentheses, semicolon. Then we better increase day, so day plus plus, simple while loop, and then at the end of that, printf, no, system.out.print, system.out.println, parentheses, quote, after growing 30 more days, dot, 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 end quote, in parentheses, semicolon. Let's call r1 dot display again. And there it goes, right? Maybe on the Ricky is growing, we could print out the age each time so that we would know, right, how many days old he was at each particular point. I kind of think I'd like to do that. Nah, not going to bother. Wish I would stop. Anyways, so here was their code for it. Rather similar. They do have a setter for the percent growth rate. It's actually the only setter that they provided. They have a grow, which increases the age. I see they did something slightly different here. They allowed you to use growth rate to be specified as 10, meaning 10%, where I was assuming that we would say 0.1 as our growth rate to mean 10%. It's all right. And then the display method prints out the age and the weight of the mouse. So the private and the public keyword access modifiers, when you put it on a member of a class, you determine how easy it is for the member to be accessed. If it's private, then that member can only be accessed from within the member's class. If we try to modify our code to change the name directly, like this, r1.name equals Fred, not going to work. Name is private, it cannot be changed that way, cannot be accessed. No way to get to it except through the members, the getters and the setters, the accessors and the mutators. So if you declare a member to be public, then the member can be accessed from anywhere in the client code or within the members inside a class. Usually make your methods public, usually make your data private. So remember Professor Thompson's rules, recommendations for making classes, guidelines for classes. 1, data private. 2, methods public. 3, ought to begin with an uppercase name, upper initial cap, but I'm going to leave that off from now on. Getters and setters. Alrighty. We're going to add a 4th recommendation, which is a constructor if it makes a class easier to use. What do I mean by that? What if I wanted to create a rat like this? What if I wanted to be able to do rat r2 is equal to new rat, parentheses, quote, Ronald, in parentheses, semicolon. And it would create the rat and already assign the name parameter, the name variable. Or maybe we'd even want to pass in that it's 0 days old and has a weight of 10 grams. Excuse me. Well, we can't do that yet, but we can provide a constructor that would allow us to set these parameters. That way we wouldn't have to call set name when we created it, or set age, or set weight. We could do it in one line, what previously took 1, 2, 3, and then 4. Right? 4 lines to do that. Just one line sets all that data. Well, we can certainly do that. We just need to remember that our constructor is going to need the name first, the age second, and then the weight third. Let's go to it. Where's our rat declared? Say I didn't have the file open. You can highlight the name of a class. You can right click and do navigate, go to source. See what I did there? Double clicked on rat, right clicked, navigate, go to source, and it takes me there. So I'm going to add a constructor. Now constructors I really do like to be the top method underneath the variables. So what is a constructor? A constructor is a method with the same name as the class and no return type. It is called when the object is being created by the new keyword. So every time we call new, it's going to call a constructor. Now there already is a constructor known as the default constructor. We don't have to provide the default constructor. If there wasn't a constructor, then that new statement that we originally had to create Ricky would not exist, would not work. Let's create our constructor. This is a customized constructor, right? The default constructor that we use down here, we didn't pass in any data, right? Just the default behavior. We want to create a constructor that does accept data. It's going to be known technically as a parameterized constructor because we can fill in parameter variables. Or, I could just call it a custom constructor. So going back up here, here's going to be my constructor. It needs to be public or else you couldn't create it. If it was private, then, well, anyways, public. It has the same name as the class with no return type. So it's not public void rat, it's just public rat, parentheses. And it takes 3 arguments, so we're going to provide 3 parameter variables. String name, comma, int age, comma, double weight, in parentheses. And we have 3 setters. I guess we could call them right in our constructor. We could just do, set name, parentheses name, set age, parentheses, Let's give that a shot. Now I have a hunch that it's going to give us some little warning off to the side if we do it this way. What I usually do is just do this dot name equals name, semicolon. This dot age equals age, semicolon. This dot weight equals weight. This reference means that the variable that follows it is part of the object. If you leave off this reference, then it means it's the parameter or the local variable. Now what I was just talking about a little bit before about calling the setters is I could have done this dot set name, parentheses name, Control S. And it's giving me a warning about that. Overridable method call in constructor. Well, we're certainly not ready to talk about what an overridable method call is. So I'm willing to accept that NetBeans is smart and that that's not the best thing to do, even though it honestly would work. So I'm going to undo that change. I'm going to delete that line. So that's our constructor. Excellent. That line of code will work. If I hit Command S or Control S, save my data, scroll back down to where I create Ronald and Ricky. Great. I can create a rat with 1 line of code rather than 4. Uh-oh, this line is broken now. When you add a custom constructor, when you add a parameterized constructor, Java stops providing the default constructor. We could fix that just by passing in, Ricky, 0, 5 right then and there. Then we could delete those lines. But I have broken my code, and maybe there's 10,000, other projects that are relying upon this rat class, and we would not want to go and modify them all. So we are going to go back, and we're going to add our default constructor. We're going to add a constructor that doesn't accept any parameter variables. It doesn't have to do anything. It could just have an empty body. Or it could create some default values. Let's do that. Here's our default constructor. Public rat, capital R, parentheses in parentheses, open brace, close brace. Now that's enough. Now our default constructor works again. But as long as we're here, we could set some default values. The name of the rat is rat. This dot name equals quote end, rat end quote. This dot age equals 0. This dot weight equals 1. Whatever the default values are. Now it will be fixed. I'm just going to do Control F, Command F. Look for Ricky. Get back down there. So when we create our rat like that, since it's a default constructor, it accesses the method we just added, which sets the name to default, the age to 0, and the weight to 1. I'd like to rearrange this just a little bit, I guess. I think I want to take this rat R2 and move it underneath all the loops and everything. So I'm going to highlight that line of code, cut it, and paste it there. Now, he's got a 10% growth rate, whereas Ricky has a 5% growth rate. So if we grow him for 33 days, he's going to be a much larger. Let's do that. Let's use another while loop. Let's reset day back to 1, but this time we're going to go 33 days, so he's grown just as many days as this one. Day equals 1, while, parentheses, day less than or equal to 33, in parentheses, R2.grow, parentheses, in parentheses, day plus plus, close curly brace. I'm going to modify my little braces down here just to indicate what they are. This is one is the end of main, and this is the end of the class. All right, now let's call our one.display, parentheses, in parentheses, R2.display, parentheses, in parentheses, semicolon. That way we can just compare the two. Each one should be 33 days old, but their weight's going to be significantly different. Oh, wait a minute. We're not calling. He doesn't have a % growth rate. I made an error here because my constructor allows us to set the name, the age, and the weight, but it does not allow us to set the % growth rate. I should go back and modify that, but instead I'm just going to do R2.set % growth rate to 10. You know what, I think I've made that mistake all along. I think I wasn't watching carefully, and no matter how the mouse grew, he didn't get any larger. I think if I look back at my last build, then he still wound up being 5 grams. That was a lapse. They both need a % growth rate. So up here, after we set R1's weight, R1.set % growth rate, parentheses, and he's going to grow 0.05. He's going to grow 5% each time. Whereas Ronald is going to grow 0.10, 10% each time. So you see what I did. I just added this line, and I added this line. And there we go. Hammer and broom, and then a green arrow. I can't say that it worked. Why do I say that? He still wound up being 5 and 10 grams. This is stuff that I should have fixed before I went on and added constructors and things like that. I wasn't paying attention. Now I need to figure out why his age and his weight is not increasing, even though his age is. There's got to be a problem, an error with my grow method. So I'm going to scroll back up and find the grow method, but as a shortcut for scrolling back up, I'm just going to double click on the word grow, right click, navigate, go to source. Right click, or double click, right click, navigate, go to source. Alrighty then, the problem is is that I increased his age that way, and I increased his weight this way. Okay, wait, I reuse the age variable. That was moronic. Let's fix that. This dot weight equals this dot weight times this dot percent growth rate. Hammer broom, green arrow, and then go. So the 5% growth rate rat wound up being 25 grams. The 10% growth rate wound up being 232. So just a moment. So here they wrote a driver class for their mouse. They add a scanner to it so that you can probably type in the growth rate. We could do something like that, and then we could ask the user how many days in a row, you know, if we wanted to grow the rat. I think we already have the concept though. So to call a method, you use the variable name, followed by the dot, followed by the method name. So that's the syntax that they're showing here. The so-called reference variable, because it's a reference to the object, a reference to the instance. The method name, and then in parentheses with the comma separated arguments. The calling object is the object that appears at the left of the dot. Gus here is a calling object. I would call it the calling reference. A reference is not actually an object, just like an address is not actually a house, but they called it the object there. That's the calling object, gus.set% growth rate. And the this reference. When you use the keyword this followed by a dot and an instance variable or method, it's called the this reference. It's a reference to this object, the object that we are currently using. Now when we say this object, that means that we are inside a class and we are referring to the object of the same class. So when we say this.name, we're saying the name of this particular object, this particular rat. Wouldn't make any sense to come down here and inside Lecture C go this.name equals no, right? In this case, this would refer to an object of this class, Lecture C. Well, we don't even have an object of this class. So, doesn't make any sense to think of it that way. Instead, we're going to say that if you use the this keyword, it means it's a reference to the object of the type of the class that you're currently in. Or in short, a reference to this object, the current instance. You don't have to use it most of the time. I could have gotten away with not having this.name equals rat, this.age equals 0. I could have removed the this references. However, I could not do that here. If I deleted that, notice the change in the color here. Name is in green here, representing that it's a member of the rat class. It's differentiated from the parameter variable by its color, right? That is that, whereas this is that. But if I took that out, it's just saying name is equal to name. Black letters, would not work at all. So if your parameter and a member share the same variable name, then you need to use the this reference to distinguish between them. One fix for that would be to give these different parameter names. You know, we could say string in and then don't make this change because I'm going to immediately undo it, name equals in. That would work. Then I would no longer need to add the this reference because the names were no longer the same. But it's industry standard and I prefer to do it as well. I'm just undoing those changes. So that in our constructor and in our setters, we use the same variable name, which is why we would want to use the this reference. Another nicety of the this reference is that you type this dot and it pops up a list of variables, saves you typing time, and a list of methods, including some we did not create, right? By default, Java gave us some methods as well, which our class inherited from the root class object. Every class you create inherits from the root class named object, the base class named object. That's a topic for another day. Okay, so I want y'all to make another class. Let's see what I think it ought to be. Am I going to provide the UML for it? Yeah, I think I will. So down here at the bottom, I'm going to just open up a multi-line comment. It's going to be the homework. We're going to create a fraction class. So, a fraction has a divisor and a numerator, right? Divisor is the thing on the bottom and the numerator is the thing on the top, like 1 over 2. So we need a numerator. It's going to be an int. We need a divisor, which is going to be an int. And yeah, I guess you could say, you know, that my value is 3 over 1.5. But normally our expressions are, you know, our fractions are in whole numbers. So let's make them ints. We need getters and setters, right? So set numerator, which is going to take an int and return nothing. And then get numerator, which doesn't take any arguments, but returns an int. We need the same thing for divisor. Now remember how easy it was when we use the refactor menu. When you create your class, if you just highlight those two variables and choose refactor and encapsulate fields, it'll go ahead and create the getters and the setters. And then set. It's not the divisor, it's the denominator. Denominator. So set denominator takes a denominator as its parameter, but returns nothing. And then get denominator doesn't have any arguments, so no parameters, but it does return an int. All right. Now what does a fraction need to do? We need to return its value, right? So when we call get value, like that, it needs to return 1 over 2, you know, or 2 over 3 or whatever. That's a fractional value, right? So we need to support decimal points. So we're going to define that as being a double. And like the rat class, we could add a display method, right? That would just print out the value of the fraction. I'm going to leave that one off. You can print the value of the fraction down in the client code. Or if you feel like adding it, great. So that's our UML. And I'm going to give you a warning that get value The calculation needs to be done very carefully. And as a matter of fact, I may provide it for you, or at least a formula for it. Inside your get value function is going to look something like this. Double result is equal to, and you're going to need to cast one of the integers to a double. Because if I just did this dot numerator divided by this dot denominator, it's going to do integer division. If you divide an int by an int, you get an int. And so if this was a 1 and this was a 2, it would return 0. Right? Because there's no fractional values allowed if this is an int and this is an int. So 1 over 2 rounded down to 0. We don't want that. We want to support, right, 1 over 2 as being 0.5. So we're going to say double result equals this numerator, and then we're going to do result equals result divided by this dot denominator. Now that's one way to do it. We could have shortened that a little bit. We could have done this. Double result equals double, in parentheses, this dot numerator divided by this dot denominator. That would have worked as well. Why not just leave it like that though? Hint. The get value function needs to take care to avoid doing integer division. This is one way you could do that. All right. So once you create your fraction class, then you should have a client class, a driver class with a main method. The main method in the driver client class, do not put main inside fraction, should ask the user to input the numerator and the denominator, and then print the value. So it ought to look like this. It ought to display something like fraction calculator. What is the numerator? Question mark, and say they type in 2. What is the denominator? Denominator, question mark, and they type in 4. And it says the value of the fraction is 0.5. That's what we want it to look like. Sample run. We'll probably expand this class, be a little bit more interesting to support multiplication and addition, things like that, so that you can multiply two fractions together. For now, this is enough for that one. Let us do one more class. This class is going to be named Triangle, and it's going to support calculating the area of the triangle. So this is part B, assuming the other one was part A. Now I'm not going to give you the UML for the triangle class. We've already had sample UMLs, so you ought to be able to figure it out yourself. So this is the UML for a fraction class. You will implement this UML as a Java class, and then add a class with a main that uses the fraction class to create an object and display its value. So that's the rest of the description, part A. Part B. Create a triangle class. It has two members. base, and height, two member variables. Oh, and by the way, these member variables up here needed to all be private, so I'm going to put minus signs on them. And these all needed to be public, so I'm going to put plus signs all on them. And I thought of one more thing I want you to do to your fraction class, which is to add a constructor for it. Nah, let's leave that off. The chapter hasn't even mentioned constructors, so I'm not going to add that to the homework. So you're going to create a triangle class that has two member variables, base and height. It has getters and setters, which are really known as accessors and mutators for the member variables. It also has a get area method, which calculates the area of the triangle according to the formula area equals base times height divided by 2. Make the member variables doubles. The main method in the client class should ask the user for the base and height of a triangle, create a triangle object, set the values, set the member variables, call the setters, and calculate and display the area. Sample run. Triangle area calculator. What is the base of the triangle? You type in 10. What is the height of the triangle? You type in 10. The area of the triangle is 50. 50.0 or whatever it's going to display. All right. I should require y'all to create the UML for this as well, but just create the code for it. So your solution, you can put this all in the same project. So your final project will contain 3 classes: the fraction class, the triangle class, and the driver class, which you could just call homework 2, right? All right, makes sense, gang? Hope so. So text me if you have any questions over this, and more next week.